Hi, Daryl Gibson here. If you're studying for the CompTIA Security Plus exam, you may find some of the cryptography topics a little challenging. A lot of people do. This video is one of a series of short videos on cryptography topics that may help you take and pass the exam the first time. It's intended to be a supplement to one of the books I've written, but you don't have to have the book to take advantage of this video. But if you are looking at the book, you can take a look at Chapter 9. Chapter 9 does expand these topics quite a bit more. So encryption, that's this first topic. Enforces confidentiality. We can encrypt it. People can't read it. It prevents unauthorized disclosure. A couple important points. Now, how can we encrypt it? We can use either symmetric or asymmetric encryption. Those are the primary ones. There's a couple others, but those are the primary ones. We'll talk about these, and we'll also talk about something known as the Rayburn Box. Primary symmetric algorithm that we use today is known as AES, Advanced Encryption Standard. It's also known as Rindale. It actually came from what was known as Rindale, but it's now known as AES. You'll see it used all sorts of places. Very fast, very efficient. It has the least processor utilization of several other symmetric algorithms, and it is very strong. It's used by the military, used by a lot of different organizations. You'll see it used in Microsoft applications, used quite a bit. There are multiple key sizes like 128, 192, 256. If it is using 256 bits, it's recognized as AES 256. Okay, now symmetric algorithm uses one key. Let's just take a look at something so we can solidify that a little bit. Here's a demo I found on the internet, but if I have an encryption, here's triple des, but if I have an encryption, what I can do is the time is now, and I can type in or click encrypt, and this is the encrypted data. Now the cool thing is I can take this away and I'll use the exact same key. This is the key, and I can decrypt that data. And that's what we're talking about with one key. The exact same key is used to take this data and encrypt it, or take the encrypted data and get the original text. Asymmetric algorithms is two keys. I'd like to say along the lines of symmetric is one key. Asymmetric, we're adding a syllable there. Now we use two keys. And these two keys are the private key and the public key, and they are matched pair. One key encrypts, the other key decrypts. In other words, if the public key encrypts something, only the private key, the matched private key, can decrypt it. Or the other way around. If the private key encrypts it, only the matched public key can decrypt it. And an important point here is that private key always stays private. The public key is freely shared. We just give that out. Anybody can have access to it that we want to be able to have access to it. But two keys, asymmetric algorithm uses two keys. Now when you understand that, it becomes a little bit easier to understand how it works. Now in the classroom, I very frequently talk about something known as the Rayburn Box. And this is a great metaphor to show how the public keys and private keys work. If I've got this Rayburn box, there's one key that can lock it, and once that key locks it, it can't unlock it. It is locked until the matching key unlocks it. So it has another key. We can stick that other key in the other keyhole, and now that other key can unlock it. All right, now once it's unlocked, this key can't lock it again. All right, this key can only unlock it once it's locked. Can't unlock it. You want to lock it, you have to go back to here. And these two keys are both matched to this box. All right, I got to fix something. There's really no such thing as a Rayburn box. All right, it's my middle name. However, there really isn't a real-world metaphor that we can show how this works. The important point to really remember here is a public key and a private key. They are matched pairs, and anytime one key encrypts, the other key can decrypt. And once a key encrypts something, it can't decrypt it. Only the matching key can. Important points. Okay, so private key, public key, one key encrypts, the other key decrypts. We keep the private key private. public key is shared. And of course, a common question lots of people ask, okay, if one key encrypts, another key decrypts, which one does which? It depends. I got another video I'll show you that you can use, but it talks about SSL. In SSL, when it uses asymmetric encryption, one key, the public key, is going to encrypt data, and the private key is going to decrypt it. If we're going to use this for a digital signature, in a digital signature, the sender's private key is used to encrypt, and then the sender's public key decrypts it. There's more videos that you can watch that shows this. Now this one is really just talking a little bit generically about encryption, the Rayburn box, and how public and private keys are. It's important to get that. Once you get that, other concepts become quite easier. I've got other videos, a couple videos I posted. One's on hashing and integrity, another one's on digital signature and how the public and private key can be used for a digital signature. Another one is on the SSL handshake process with HTTPS and how the public and private key is used for that. Hope this helped. Take care.